Yes, we start again. We have this numerical here. It says 3 identical spheres shell of mass m and radius r are placed as shown in this diagram. Okay. Consider as axis xx dash, which is touching to 2 shells and passing through diameter of the third shell. So this is the axis. Now if it is axis of rotation, how will be the rotation? The answer is this is the rotation. Right? It will rotate like this. Moment of inertia of the complete system consisting these 3 spherical shells about xx dash, and we have to find out which one is the moment of inertia. Now in this, because all these are rotating and there are 3 parts, the first thing what we apply, that the moment of inertia will be sum of all the 3. That is, the total moment of inertia will be sum of moment of inertia because of first, second and third. 3. We have to find out moment of inertia of all the 3. Now we start it again. See the top one. First sphere, about this axis, it is rotating. A sphere which is rotating about its axis has a moment of inertia, and we know that that moment of inertia is 2 upon 3 mr square. This axis is passing through center of mass. Because it is passing through center of mass, that application, that formula will be applied, 2 upon 3 mr square. But that is not the case in this sphere. It is not passing through the center of this. It is passing from one side, tangential. And this thing we have done in parallel theorem. We know the moment of inertia about a sphere, about an axis which is passing through the center, and this is parallel axis. So we will apply parallel axis theorem to find moment of inertia of this particular sphere. The same is the case for this sphere. Then once we know the moment of inertia of all the 3 spheres, there will be a simple scalar addition of all the 3. So we start finding it. Okay. So the moment of inertia of the first spherical shell is 2 upon 3 mr square. Moment of inertia of the second spherical shell, I2, that is moment of inertia of parallel axis theorem, that is 2 upon 3 mr square is 2 upon 3 mr square is about the center, plus the total mass is m and this distance is r. M into r square. This the second term. So in this way this will be 2 upon 3 mr square, that is ICM, plus m into this distance square r square. And that comes to 5 upon 3 mr square. This is for the one, and the same should be for the second one. 5 upon 3 mr square, I3. So we have got I1, I2, I3. And then we add up all the 3. When we add up all the 3, you get it 4 mr square. Is it clear? So this is our answer to it. 4 mr square. Correct? That is option D. So this is how it is solved.
A mass m moves in a circle on a horizontal plane. There is a plane horizontal, and yes, there is a, this one. A mass m moves in a circle on a horizontal plane with a velocity v0 at a radius r0. The mass attached to the string which passes through a smooth hole in the plane, the tension in the string increases gradually, and finally m moves in a circle of radius r0 upon 2. The radius decrease. What is the final value of kinetic energy? We are supposed to find out. This is a plane. In the plane at the center there is a hole. From that hole this string comes down, right? And this is the mass which is rotating. When it is rotating, we know there is a force. What is that force? Okay, tell me the name of the force which is pushing it outward. Centrifugal. And it should move outward. Why it is not moving outward? Because it is being balanced by tension. Right? So now you understand who are balancing each other? Tension and centrifugal force. Now if we increase the tension, if we pull it down by increasing the tension, what will happen to this string? Length of the string will go on decreasing. So that string which was having length R0 has become R0 upon 2. Right? Now you see the question. A mass M moves in a circle on the horizontal plane with velocity V0, radius R0. The mass attached to the string passes through a smooth hole in the plane, as in the figure. The tension in the string increases gradually, and finally M moves in a circle of radius R0 upon 2. Radius has become half. The final value of the kinetic energy, now we are supposed to find out. Which are the quantities which are known to us? Mass, velocity. Right? We have to find out answer in 2. Mass is the radius, V is the initial velocity with which it was rotating. Okay, please do it. What is conserved? That is the main thing I want to ask. When it was at higher radius and when it has come to R0 upon 2, which quantity is conserved? Angular momentum. That's right. Angular momentum is conserved. Initially, when the velocity is V0, how much is the kinetic energy? Half mv0 square. Okay. Then we decrease the radius. When we decrease the radius, what quantity, which other quantity is affected and which is not affected? This I want to know. I am not interested in A, B, C. Which one you are taking? Okay, tell me, when we pull it down and this comes here, which quantity is not changing, you just told me? Very good. And what is changing? Radius of rotation. It has become half. Okay, so you will write a formula, that is angular momentum with radius r and angular momentum with radius r0. Both angular momentum will be equal. Then what is going to change? Velocity is going to change. You will find new velocity. Right? With that equation, when you find the new velocity, then you can always find out new kinetic energy with that. This is the process, thinking process, you understand now? Okay, so we are doing it that way. This is the initial energy, half mv0 square, and what is, okay, v dash become the new velocity, let us suppose. Then first case mv0 r1, what is this? Angular momentum. In the second case mv dash, and r has become r0 upon 2. Right? So we find the value of new velocity, which is v0 here, and equating the both we get the velocity v0. M is cancelled and r0 is cancelled, and we get the value of v0, which comes to be 2v0. Now we find the energy once again, that is half m velocity square, and it comes to 2 mv0 square. Right? So you tell me one thing, we can make a formula with this, and that formula is, if we are decreasing the radius by 1 upon 2, how much energy increases? 2 times. If I decrease it 1 upon 3, 3 times. If I increase it 1 upon 4, 4 times. Remember? Inversely proportionate to the power 1. So, if it remains in your mind and you get this in your exam, you can simply go for tick. You may not have to solve the whole thing. So, you will save time on that. Okay. Pardon? 4 times? What was initially? Half mv square. Now it is 2 mv square. So it has increased. Remember 4 times? How many r is reduced? How many times? 2 times. So this energy increases. And if r decrease 3 times? 9 times. And if r decrease 4 times? 16 times. Okay. Now you remember this. Okay. So now you will surely remember this. Right? Okay. We go to the next question. This we have already done. We have discussed it in detail. So we go to the next question. Yes. Have you done it? No. A uniform metallic rod rotates about its perpendicular bisector with constant angular speed. If it is heated uniformly to raise its temperature slightly, then what are the following 4 effects? You have to choose one of these effects. Okay, we know what will happen with the increase of temperature. What will increase? Length will increase. And when the length increase, then what increases? What is asked from us? Speed of rotation, speed of rotation, speed of rotation, speed of rotation. Speed of rotation is omega. Temperature is not related to omega, we know. Omega is related to what? Omega is related to radius. How? When the length is increasing, moment of inertia will change. This is clear to you? Length increase, moment of inertia change. Moment of inertia will increase. How moment of inertia in a rotation related to omega? Tell me the formula. No. Okay. First thing, when a body is rotating, no external force applied, we are increasing the length or anything. What remain constant? Angular momentum remain constant. That means L remain constant. And how L, angular momentum, is related to omega? Tell the formula. I into omega. And L is equal to I into omega. Okay. Now L is not changing. So in first case I1 omega 1 is equal to, in second case I2 omega 2. Okay. What is changing? I. What happens to I when the length increase? Length increase, I increase. So what will happen to omega? Omega will decrease. So you got it? The speed of rotation decrease. Is it clear? Okay. Many people knew it first that B is the right answer. How? I don't know how. This is the way we should think. Right? So we should go by reason that way. Now we go to the next question. Okay. This is the answer for this. L is equal to I omega. That remain constant. Heating, the radius of rotation increases, L increase. Omega decrease. Therefore our answer will be B. Right? Okay. Now we go to the next question. Please read it. Try to think what should be the diagram of it and what should be the answer of it. Okay. A massless rod S having length 2L has equal point masses attached to its two ends, and the rod is rotating about an axis which is passing through its center and making an angle alpha with the axis. Here it is. This is the rod. This is the axis of rotation. How much angle? Alpha, passing through the center. And if this rod is rotating about this axis, how it will rotate? This way. This end will move in this circle, that end will move in that circle, and you all know this will move like this. Okay? Right. So this is what is mentioned there. Now, again, we come to the question. The rod is rotating about an axis passing through its center and making angle alpha with the axis. The magnitude of change of momentum of the rod dl by dt, rate of change dl by dt, we are supposed to find out. How can we find it out? Very simple. We will find out the expression for L. Expression for L and then differentiate it with respect to t. So we will find dl by dt. So what is our target now? To find out expression for angular momentum L. Here it is. Change in momentum is dl by dt, that we are supposed to find out. Now, L is equal to, what is the standard formula? M, V and R. What is R here? Radius of rotation. Okay. If it is radius of rotation, where is the radius of rotation? The answer is radius of rotation is here. This is radius of rotation. Right? Now, this we are supposed to fill up there, and what is given to us? Given to us is length. That is this. Okay? Length is given to us. Now, what is the relation between the two? R is equal to L sine alpha. It is perpendicular. So R is equal to L sine alpha. Okay. Now, angular momentum capital L is equal to, here, L is equal to mvr. So we put M as M and V we can write as R omega. Right? So this will be R omega multiplied by R. That will be R square omega. Now R square omega, and this R has been replaced with L sine alpha. So this is L square sine square alpha, and here you have got the expression of L in terms of alpha, that is the variable. So which is the base quantity alpha and which is the dependent quantity L. Right. The function of also L is a function of alpha. But we are supposed to find out rate of change of L with respect to time. We want dl by dt, so it has to be a function of a function. That way we can do it. We want dl by dt. So what do we do? dl by d alpha and d alpha by dt. This you have done in differentiation. Because L is a function of alpha, first we will have to do dl by d alpha, and because we want it for time, then multiply by d alpha by dt. Now it's a small mathematics. dl by d alpha differentiated with respect to alpha, m, omega and L square are constant. Okay? Sorry, not sine alpha square is equal to 2 sine alpha cos alpha, and all you do it in 2 steps, you will get this as answer. Right? That differentiation, you know, you can do that. So this is answer for dl by dt. So you get here option B as the correct option. Mi square omega square sine theta 2 theta is equal to sine 2 theta, or that is sine 2 alpha. Here you get it. Right? d alpha by dt is what? Nobody has asked me what happens to this d alpha by dt. Everybody say yes, ho gaya. Yes. That d alpha by dt, rate of change of angle, that is omega. That is why this 1 omega has become omega to the power 2. Is that clear? Okay, very good. So now we go to the next question. Please see this. A particle travels in a circle of radius 20 centimeter at a uniform increasing speed. Speed is increasing, right? If the speed changes from 8 meter per second to 9 meter per second in 2 seconds, the speed is changing. That means what type of motion it is? Accelerated motion. And that acceleration is also given to us. What is the earlier speed? 8. It changes to 9. Change in speed divided by time, 2 seconds. That will give the acceleration. Now, can anybody tell what type of acceleration it is? Centripetal, tangential, angular. Which one is this? This is tangential. Because the body is moving along the circumference and its speed changes from 8 to 9. So that change is along the tangent. So it is tangential acceleration which is given to us. What would be angular acceleration? What is the relation of tangential acceleration to angular acceleration? Very good. It is a very simple one-line formula. A and alpha. You know the relation? Tangential acceleration is A along the speed. So alpha and A. What is that relation? A is equal to R alpha. So alpha is equal to A upon R, and this is how we can solve it. Velocity final 9, initial 8, then alpha is equal to change in angular velocity. Change in angular velocity. First angular velocity Vf upon R minus this final initial angular velocity divided by time. So it comes to this. You do it yourself, you will get the same answer. That will take less time. So B option is correct this way. Able to do it? Okay. Please see this question. This we have discussed yesterday. Same thing. So what will be the answer? Remain constant. That is B. Now we go to the next question. A uniform sphere of mass 500 gram rolled without slipping on a plane surface. On a plane surface, not inclined. Okay, so that its center moves at a speed of 0.02 meter per second. What type of motion is this? Rolling motion, and that wheel is moving, linear velocity is given to us, 0.02 meter per second. The total kinetic energy of rolling sphere, that you have done yesterday. Please do it now. What type of energies will it contain? Linear as well as rotational. So what will be your initial formula? Half mv square plus half I omega square. Which are the quantities given in this question? mv or I omega? In this, what is given? mv. So what will you convert? I and omega you will convert into m and v here. Half mv square, half I omega square. Because m and v are given, we will break up this one to convert it into m. The omega to be converted to v. Understand? If I and omega is given to us, then we will convert this into I omega. Right. So please convert it and find out the answer. Okay. We go to the next question. Please come. solid cylinder of mass m and radius start rolling down on inclined plane of inclination theta. Friction is enough to prevent slipping. Why this sentence is there? It shows that the motion is not a sliding motion, it is a rolling motion. If there is no friction, then it will not roll. What will happen? It will slide down. Okay. Friction is enough to prevent slip. Find the speed of its center of mass when its center of mass has fallen a height of h. What you are supposed to find out? Speed. Do you know the formula? Okay. But here, when it comes down, then these are the two positions. And what is the difference of height? H is the difference of height. Now energy difference we can find out. How we can find out energy difference? By this H. From this point to this point, the energy difference is mgh. And once you know the energy difference, what will you know? You will know this. This is E1 here. And when it is rolling and coming here, how much energy it has? Now it has two types of energy. One is linear energy and one is this. This is the energy later. And if we take the difference of the two energy, that will be equal to mgh. Yes. So with that you can always find out the value of velocity. Okay. Once again, can you convert it into V? Because we want to find out velocity. Because we want to find velocity, we must convert it into V. So what is to be converted? I and omega. Omega has a relation V square upon R square. I, we will see the body. What type of body it is? It is a cylinder, solid cylinder. For solid cylinder, what is the formula? Yes, mr square upon 2. So this is mr square upon 2 and this is v square upon r square. Do the calculations, how much it comes to? How much? 1/4. This is 1/4 mv square. No. Yes, 1/4 and half will become 3/4. So total energy is 3/4 mv square. And this 3/4 mv square is equal to which energy? Please concentrate here. How much energy gained from this position to this position? mgh. That is equal to energy gain. And we have calculated that what is the energy here? This one. So this should be equal to mgh. And this you have just now converted 3/4 into mv square. Have you done it? So that 3/4 mv square is equal to mgh. 3/4 mv square is equal to mgh. And with that you can find the value of v square. How much it comes to? Yes. √4/3 gh. Is it clear to all? Okay. A small solid cylinder of radius r is released coaxially from a point A inside a fixed large cylinder bowl of radius capital R as shown in this diagram. This is a small cylinder, small r. This is a large cylinder and that is sent from there, so it comes rolling. Understand? Like this chalk If I leave it in a large pipe, it will come rolling here. So, what is our question? If the friction between, is sufficient enough to prevent slipping, then find out. What is to be found out here? Question A. What fraction of total energy are translational and rotational when the two small cylinders reach bottom of the large one? When small cylinder reaches the bottom. Okay. What is fraction of total energy are translational and rotational? We know that when it is coming down, it is rolling. And also it is having some linear velocity. So it has got translational kinetic energy and rolling kinetic energy. Suppose its total energy was there 10. Here this is 4. So we have to find the answer 4 upon 10, and this will be 6 upon 10. That is what is asked in the question. Please see the question. It says, what fraction of the total energy? So we have to find out fraction. And the second is, normal force exerted by the small cylinder on the large one when it is at the bottom. Normal force. Why it should apply, why this question is asked. Normal force, this is applying force on it. Same is the reaction, normal force. How much will be that equal to? mg. That's all. That is why the question is asked. Because it is not only mg. Come on, come on. No. Any particle which is moving in a circle. What is the compulsory condition I told you? It should have a centripetal or centrifugal force. So when it comes down, who is providing the centripetal force? Pushed by the larger pipe. Because it is having a centrifugal force, it tries to go out. Who is pushing it back? The bowl. So some extra force has to be there. How much is that extra force, centrifugal force? That is mv square upon r. mv square upon r is the one force it is pressing because of the rotation. And how much is the force because of its weight? mg. So how much is the total force it is pressing? mg plus? Yes, that is the total force. You understand? Because it is rotating, it is pressing it, it is pressing the ball with centrifugal force. Remember, you have many examples of that. When we go on a roller coaster, our body presses the chair back and the chair presses back. What is that force? mv square upon r, centrifugal force. The same thing is happening here. So the question is given whether you can make out, whether you remember that anything which is in a circular motion has to experience centripetal or centrifugal forces. That has to be taken into account. And because it is under gravity, mg has to be there. So we must add both of them. Now you can please make it. Go ahead. First thing is what? What fraction of the total energy are translational and rotational? When it starts from the top, any data is given? No data is given. R is the radius and capital R is the radius. How much energy should it have? Total energy. It has come from this height to this height. How much is the total energy? mgr, correct? With the formula mgh. That is the total of energy. So that one data has come to you. What is the total energy? mgr, note it down. Now we have to find out rolling and yes. When it comes here, Then what are the different? K translational, half mv square if velocity is here. K rotational, half I omega square. What is the formula for I for cylinder? Half mv square. This is half mr square. With omega square it becomes 1/4 mv square. So how much is the total? 3/4 mv square. Right? That 3/4 mv square is the total energy. 3/4 mv square is the total energy. We got it? And how much was the energy initially you learnt? Okay. So what is the ratio? No. Not finding it. Okay, let's change it. The total energy is for anything is half mv square. Here it is 3/4 mv square. Right? It is in shortcut. Please see here. First, how much is K translational? K translational. How much it is? Half mv square. How much is total energy? Yes. So half mv square upon 3/4 mv square. How much you get it? 2/3. That is the ratio. Understand? Translational divided by total. You calculated the total is how much? 3/4 mv square. How much is the translational? Half mv square. What is the ratio? 2/3. Now find out the other ratio. This ratio. How much is the rotational energy? You converted it. So numerator will be 1/4 mv square divided by total 3/4 mv square. How much it comes to? 1/3. Got the answer? Okay. So this is for A. Now for B. Okay. What is the second part of it? To find centripetal force so that we can add it with mg. Please listen here. In the second part, what we are supposed to find out here. The normal force by a small cylinder on the large cylinder, and that we have decided is equal to mg plus mv square upon r. What is that r? Radius of rotation. Okay. Now in this diagram, see radius of rotation. The radius starts from this point. The radius of rotation. Where is the rotation? Here is the rotation. Is this rotation having radius capital R or little less than that? How much it is? So what is centripetal force now? mv square upon? That is what we are supposed to find out. And here you see mg into r minus r. What is this? This is potential energy. Understand? Because how much it has fallen down? This has fallen down by r minus r. So how much is the total energy it has got? mg into r minus r. If this is the total energy, then it is equal to what? This is equal to 3/4 of mv square. Is that clear? You got by the formula that total energy was how much? Half plus 1/4. That was 3/4 mv square. With the formula of potential energy, we could find out that this is equal to mg into r minus r. These two are equal. Okay, cancel out m. And what do we want? We want mv square upon r minus r. So mv square is here. Transfer this r minus r here. Rest everything there. What do you get? mv square upon r is equal to 4/3 mg. This is which force? Centripetal force. And what is our total force? Centripetal plus
mg. So add 1 mg with this. 4 upon 3 mg plus 1 mg. How much it will come to?
7 by 3 mg. This is how we make it. Is this point clear? Okay. Whatever you want to note down, do it so that we go to the next question. Yes, any doubt? R minus small r 2. Why it should be 2? Yes, the total height up to the bottom. How much it is from this point to this point? Capital R. And only this much is to be reduced. That is small r. So this center, which was here, the center was here, it has come here. The center was here, it has come here. Up to this it is capital R, this is small r, so the remaining is r minus r, and that is the radius of rotation, and that is the height up to which it has come down. So in all the cases it will be r minus r and not 2r. Understand? Okay. We have to take up to center of mass. Now we go to the next question. Should we? Yes, see this question. A solid ball of radius this and mass 1 kg is given an instantaneous impulse of 50 Newton second at a point P as shown in the figure. This is a golf ball kept on the ground, and when we hit it, there is an impulse. It has been hit at this point P, right? Now when we hit it, there is some action on it, and they are asking us, find the number of rotations made by the ball about its diameter before hitting the ground. How does a golf ball goes? When we hit a golf ball, what is the type of motion it is showing? Very good. Projectile motion. You all have seen that? The golf ball goes in a projectile, right? So it will go in a projectile. Now they say the ball is kept in the smooth initially, and find the number of rotation made by the ball about its diameter before hitting the ground. Before hitting the ground means what? It is already on the ground. What does that mean, before hitting the ground? Yes, because I have told you, otherwise you have to think. A ball is on the ground, then how it will hit the ground? First it has to rise and leap. That is why I thought that it is a projectile and this ball must be a golf ball. Understand? Because that is hit in this way, and that goes as a projectile, and then again it hit the ground. And that is the language used. Again it hit the ground. So what should be the motion? Yeah, we can assume it is a projectile motion. Now in that projectile motion, we don't know. They are informing us what? Find the number of. That means it must be rotating. And he is asking how many number of rotations will it have completed when it is hitting the ground again. This is the question you have to make. Can you make any ends meet? Think. It's a rotational motion question. What you are supposed to find out? Let us go for thinking process. What we are supposed to find out? Number of rotations. Which are the quantities where, or which are the rotational relations where this number of rotation n is involved? Any formula where you have this n. Formula related to angular acceleration, angular velocity, angular displacement. Yeah, tell me. Pardon? Angular? Okay. How n is involved in the formula of angular velocity? Please tell me. Why you all know it? When I tell, yes, what? 2 pi? 2 pi r upon time. 2 pi r is what? Total circumference divided by time. What does it give us? Omega. Where is n? Number of rotations. But this approach is correct, I tell you. You will find here, modify it a little. If a particle, I tell you, if a particle is making n rotation per minute or per second, which are the two quantities you can? Pardon? Let us start thinking it. Okay, what is the action being taken? I have shown it here. Please see. When we hit it here, two things happen. Number one, this force here has a component in this direction. What is the angle made? 30. When there is a hit in 30 direction, there is a reaction from the ground for reflection. How much will be that angle? Same as 30, this will also be 30. This line comes here. As per law of reflection, if this angle is 30, then this will also be 30. Right? Okay. So, when this ball bounces because of this hit, what will be this angle? 30. Can you make it geometrically? Yes, this is 30, this is 90. How much will be this one? 60. Correct? If this is 60, then 60, 90. And how much this will be? 30. Okay? Or you can simply say horizontal lines. This is the, this is 30, so this will also be 30. If this is 30, angle of incidence, then angle of reflection will also be 30. So this is angle 30. So when this ball jumps into projectile, what is our angle of projection? 30. You got it. This is what angle of projection. But will it start projection from here or from here? It will start from the point of contact. So this is the, we can assume, this is the trajectory of this ball. Starting with an angle, how much? 30. Remember, projectile starts with 30-degree angle. Okay, this is, we assume, this is something which is happening. But what we are supposed to find out, number of rotations. Again, we have to think on that line, and this is our line of thinking. Number of rotations is angular displacement divided by 2 pi. If I tell you, yes, a particle has moved 760 degree, no, 720 degree, how many rotations? Why silent? Yes. If I tell you a particle has moved theta degree, how will you find out rotations? Theta divided by 2 pi. So, angular displacement divided by 2 pi. What gives us? Number of? Yes. That should come to our mind. Understand? And this is something which we cannot give you as a guest paper or a trick. You must have the knowledge. The number of turns, how we get? Total displacement divided by 2 pi or 360 degree. Right. So in this, which angular quantity is involved? Angular displacement. And angular displacement theta is equal to omega t. So, and we get the formula omega t upon 2 pi. That will give us the answer. Now in this, which are the two quantities you need? Omega t. T is what? Total time till what? Till which it keeps on rotating. And how much is that time? That is time of flight. What is that time? Time of flight. So, projectile motion is involved in it. In a very good competitive examination, whether it is AIMS or JEE, IIT, or a difficult question of NEET, mostly two or three principles are involved together. So they have involved here, you have to get the time through what? Projectile motion. And then you will have to apply rotational motion with that omega t upon 2 pi. So now our target is fixed. We need only two quantities. One is t, one is omega. Okay. Let us start with this. So this is our understanding. This is known as thought process. In the thought process, when you are seeing a numerical, how do you start? You search for the line of question which is asking you for this number of rotations. So we search number of rotations, what should be the formula, or how many formulas we know. If you know more than one formula there are, then we will see for which formula adequate data is given. We will proceed on that. So we start from that. So we started with this and we came to know that we are in need of omega and t. That makes us elevation one step. Now t, because we have thought of it is a projectile motion, we will remember what is the formula for t in projectile motion. For t, what we need? We need, yes, this is the formula for t. This you have seen? Okay. This one. For this, we will find t. But again for this, which are the data required? U and sine theta. You know theta. Done? What you know now? What you need now? U, velocity. Please come back to the question. Where is velocity here? Velocity is there. Very good. Impulse. What is the formula for impulse? M into V. Okay. If you want difference of the impulse, that is again mv. Why it is mv? Yes. Final minus initial. Change in impulse mv minus mu. U was 0. So what is the formula for mv? That is impulse. How much it is? 15. So m is given 1 kg. So how much velocity we get? 50 meter per second is initial velocity. So for projectile motion, this is initial velocity. Is this right? Okay, what we need is, impulse upon mass. This gives us value of u, and here we have got u. How much is theta? 30 degree. So 2u sine theta divided by g. That gives us the time. How much that time comes to? 5 seconds. Okay. So we got the time of flight. It is 5 seconds. Right? So this is time. Now we have to find omega. Impulse give angular impulse also. How? What is angular momentum? L equal to mvr. What is mv equal to? So impulse into r. Where is impulse into r? Here. Are you able to see? This is impulse and this is the perpendicular distance, r, from the center of mass. This r. How much is this r equal to with reference to radius? We know it. That is equal to r sine theta. This is 30, right? and this is r. So how much is this perpendicular? R sine 30. That is equal to small r. So when we are calculating, yes, MVR, what is r we are going to take? R sine 30. And MV we are taking as impulse, right? Okay. So we put this value, impulse into r sine theta. Impulse into r into sine 30 is 1 upon 2. 1 upon 2. And what is I? I for the ball is 2 upon 5 mr square. Right? After that, we have mathematical calculation. Look here, everybody. This 5 will go above here. Impulse 50. This 5 has gone here. R. Yes, this R is how much? R and R square. They cancel out. There will be one R here. That R is 0.2. Come to the bottom. This 2 is here. M is 1 kg. This 1 R is 0.2 and this sine 30 is 1 upon 2. So we do all this calculation and this calculation comes to 312.5. So this is value of what? Omega. This is value of omega. So you got omega this way. How this is value of omega? Because we have calculated here. L has got two formulas. Which are the two formulas? One is MVR. Which is the other one? I omega. That will give us omega. So we have written I omega is equal to MVR. That is I omega is equal to impulse into R. So impulse MV, we have put the value here. Impulse, we don't have to find M and V. Impulse, the total value is given in the question as 50. So that we have written as 50. Right? And this, we have written R sine theta here. Now this I is transferred to the denominator, that is this 2 upon 5 mr square. So what we get here is this omega. Is this point clear? How we get? So we are using two formulas of angular momentum. One is I omega, other is MVR. With help of that we can find out omega, because rest everything is given in the question. So now we have got omega and we have got T. These are the two things we were asking for, and here you will get it. N is equal to omega T upon 2 pi. And we got it. How many rounds it will have before falling? 249. Okay? So you have noted it? Anybody? Omega is equal to V upon R at which point? That is in a circular motion. That is in a circular motion. We must know velocity at the circumference. So which is the V you are talking about? Which V? That 50. 50 is V divided by R. If you do it, what will come? How much it is coming? How much it is coming? 500. The final answer. Omega. That is right. Okay. You have done this question? Now, I ask you, this I made in the morning, just before coming here, I typed it. And now I realize I have done a mistake. So, I ask you, please find out that mistake. Just now I noticed, while explaining you, that I have done a mistake. Could anybody notice it? No. Please see this. Here. What is the U we have taken in projectile motion? Here. What is the value of u we have taken? 50. Now 50 is velocity of what? Yes, the strike of the ball. What is its direction? And what is u? Here, in this direction. This is, if this is 50, this is not 50. What it should be? 50 is in this direction. So what it should be? 50? Sine or cos? If 50 is here, then we can make two components, one in this direction, one in this direction, vertical, and one is in this direction. What will be that? That will be 50 cos 30. So what u should I have taken? Yes, cos 30 is not half. So that will be, yes, root 3 by 2. So in place of 50, what we should have taken? 50, 25 root 3. 25 root 3. Okay? If you take that, then our time will change. Can you find out here how much it will be? 5, how root 3 will affect it? Pardon? This will be how much? Please don't mix up decimal in it. You do it, that will be right, no problem. 4.2. 4.3, that is closer. Okay. Now, if you use here 4.3 in place of 5. Oh, it has decreased. I thought it will increase and become 500. No. It has decreased. It has become 250. Okay. In place of 5 seconds, please use that 4.3. Do that multiplication. Yeah, it comes to 265. 265.5. That is the value of omega. And if that value we multiply here with t, that is the value of t. No, omega. Omega is to be multiplied with t. What was the value of t? 4.3. How much it comes to now? 182? Yeah. Is it? 190? 199. That is 200. Almost. Okay. So you can do it. Okay. Result does not matter because of the square root, because of the root 3. It may be different slightly here and there. But you understand the method of it? Right? In a projectile motion, what we will find out? T. And putting the value of L, that is I omega is equal to mvr. What we are going to find out? Omega. Then omega multiplied by T divided by 2 pi. That will give number of rotations. So this is how it has to be done. You can do the multiplication once or twice and you will find it. For the u of projectile, you should use u cos theta, right? So that will give the correct value of u, and after that you can find out the time, right? So we close it here.